So we're going to be talking about section 18.1 and 18.2a, which are dealing with trigonometric ratios. So the very first thing we're going to do is we're going to define what is a trig ratio. And a trig ratio is just a comparison of two sides of a right triangle. Now, very important word. This only works with right triangles. Only works with right triangles. So what I'm going to do over here is I'm going to put a big picture. I'm going to make a big right triangle over on the left. And I'm going to label that right triangle A, B, C. Now, across from the 90 on a right triangle is always the hypotenuse. So I'm reminding you of that. And then how you label the sides, across from angle A or big A, across from it, which is opposite, is little a. Across from big B, which is opposite, is little b. Across from big C is little c. So we're going to start out just by labeling our sides. Now, trigonometric ratios are dealing with those three keys on your calculator that you've seen but you probably haven't used yet, which are sine, cosine, and tan. So we're going to start off with dealing with sine. And sine is just opposite over hypotenuse. Or, if we abbreviate it and use it the way it is normally seen on a calculator, it's sine, you call that sine even though it says sin, equals opposite, and we're just going to do O over hypotenuse H. Then we have cosine. So I'm going to write cosine. Cosine is adjacent over hypotenuse. Abbreviation for cosine on the calculator is COS. And adjacent, so we're going to use little a over hypotenuse, H. Then we go to tangent. Tangent is opposite over adjacent, which if we use the abbreviations, it's tangent equals opposite over adjacent. So now that we have that, a quick memory device so that you can remember this is sa or so, ka, to, So there's sine is opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. SOHCAHTOA. It's kind of just a memory device so that you can remember it. So now, if we're looking at this right triangle that we were just dealing with, and we're trying to find the sine, cosine, and tan, the trig ratios of a certain angle. Now, we never do it for the right angle. We always do it either for angle A and angle B. I'm going to choose angle A. Since I'm choosing angle A, I'm going to label my sides appropriately. So across from angle A is the opposite. And we already know what's the hypotenuse. It's always across from the 90. So that leaves the other side as being adjacent. So now, knowing that, I'm going to go ahead and write my sine, cosine, and tan of angle A. So that means the sine of angle A is opposite, which is little a, over hypotenuse, little c. Then cosine of angle A is adjacent, little b, over little c. Then tangent of A is opposite, little a, over adjacent, little b. Now, if we were to do angle B, it's going to be a little bit different. So if I was to look at sine of angle B, so what's opposite of angle B now? Now it's little b. Over hypotenuse, little c. Cosine of angle B is adjacent of angle B, so now that's little a. Little a over c. Tangent of angle B is opposite, which is little b, over adjacent, little a. Now, one thing you should notice is that these are the same. And these are the same. And why is that? It's because these two angles right here are complementary. Since they are complementary, their sine and cosines of the opposite angles should be the same. Vice versa. It goes each way. So now what we're going to do is we're going to actually start doing some problems using this concept. And all we're going to do is try to find the trig ratios. So the directions are going to be to find the trig ratios of angle A. And in order to do that, we have to be given a right triangle. So I'm going to draw the right triangle right here. So here's angle A, here's angle B, here's angle C. Now, what they're giving you is they're giving you that this is 36 meters, this is 39 meters, and this is 15 meters. We're given that. So now, since we're talking about angle A, I'm going to circle angle A because that's the one I'm dealing with. Now, we automatically know that this is hypotenuse, so I'm going to call that H. Across from angle A is going to be opposite, so I'm going to label that O, which means the only one that's left is the adjacent, or A. So to do my trig ratios, I would go sine of angle A is opposite. What's opposite? 36. Over hypotenuse, 39. That can be, both of those are divisible by 3, so it could be reduced to 12 over 13. Then cosine of angle A is adjacent, 15 over hypotenuse, 39. Both of them are divisible by 3, which gives you 5/13. Then we do tangent of angle A. Opposite, 36, over adjacent, 15. Both divisible by 3, and we get 12/5. Now, when we look at those, if all it asked for was our trig ratios, we are done. It just wants you to write it as a fraction. But sometimes they'll ask you to go one step further, which means they're going to ask you to plug it in your calculator and simplify it. So if I do that, I would just go in my calculator and I would go 12 divided by 13. Now, if it doesn't say how many decimal places, we usually do it to 3 decimal places. So I would say that this one's approximately 0.923. The next one would be 5 divided by 13. That one's approximately 0.385. The next one, 12 divided by 5, and that is actually equal to, so it's not approximate, because we're not rounding off on this one. It's going to be equal to 2.4. So if it asks you to put it as a decimal, you put it as a decimal. If it doesn't, it's just asking for the ratios, just like what I have right there. We're going to do one more problem where we're going to deal with ratios. So same directions for this next problem, and I'm going to draw my right triangle again. This time it's going to go the opposite direction. C is here, A is here, B is there. We're given that the hypotenuse is 15, we're given this is 12, and we're given that this is 9. And it's wanting for angle A again. So I'm going to circle angle A. And in relationship to angle A, this is hypotenuse still. Hypotenuse never changes. Opposite of angle A is over here, which means the last one is adjacent. So then if I'm going to work that and do my ratios, I do sine of A is opposite 9 over hypotenuse 15. What are those both divisible by? 3 again. So this is 3/5. Then we do cosine of A. It's adjacent 12 over hypotenuse 15. Both divisible by 3 again, and we get 4/5. Then we do tangent of A, which is opposite 9 over adjacent 12. Both divisible by 3, and we get 3/4. Now, once again, trig ratios, we're done. But if they're asking you to put it as a decimal, you work that out. So 3 divided by 5 makes 0.6, and that's exact. 4 divided by 5 is 0.8, and that's exact. 3 divided by 4 is 0.75. If they don't ask for the decimal, you're better leaving it as a fraction. Now, the next type of problems, on these, we're going to be asked to find the unknown angles and sides. Find the unknown angles and sides. So we're always going to be starting off with the right triangle. So I'm going to draw my right triangle. There's my right triangle. And angle A, angle B, angle C. Now, for this one, what we're given is we're given that the hypotenuse is 70 feet, and we're given that angle A is 42 degrees. Now, it's wanting us to find all angles and sides. So that I don't forget any of them, I'm going to go ahead and make a chart over here. Okay? And I'm going to do angle A, angle B, angle C, and then I'm going to do little a, little b, little c, because I want to find all the angles, all the sides. Now, we know that angle A is 42 degrees. We know that angle C is 90 degrees. And we know the 70. What is the 70? Is it little a, little b, little c? It's across from the big C, so it's little c. Now, easy thing. We're going to, what angle are we given? We're given angle A. So I'm circling the one that we're given. Now, how do we find angle B? Is we know a triangle adds up to 180. So to find angle B, all we do is 180 minus 42 minus 90. And what do we get? 48 degrees, which means angle B is 48 degrees. Not a lot of work for that one. Now, to deal with little a and little b, we look at our right triangle. So I circled angle A, and I'm going to label my sides. So across from big A is little a, across from big B is little b. Also, I'm going to label them based on our trig functions. What do we know? 70 is the hypotenuse. Across from angle A is the opposite, which means little b is adjacent. So I'm labeling them by what they are. So what we are given is we're given angle A and we're given the hypotenuse. So out of our trig ratios, which ones use the hypotenuse? The two that use hypotenuse are sine and cosine. So those are the two trig ratios I'm going to use to be able to find little a and little b. So I'm going to start off with sine. So sine of A, and we know that A is 42, is equal to opposite, which is little a, over hypotenuse, 70. Now, if I want to solve for little a, I basically just have a ratio. How have we been solving ratios? We've been cross-multiplying. So if I cross-multiply here, I get 70 times sine of 42 equals a. I'm going to leave it like that right now. We'll come back to it in just a second. Then we said what other ratio uses hypotenuse? That was cosine. So then I'm going to do cosine of 42. It equals adjacent, which is little b, over hypotenuse, 70. Same concept here. Got my ratios, cross multiply and solve. So I get 70 times cosine of 42 equals b. Now, first thing we need to do on our calculator before we even plug those in is we need to make sure that our mode that we are in degrees. So how you figure out whether you're in degrees is I'm going to go to mode, and if you notice, if I scroll down, right now I'm in radians and I want to be in degrees, so I'm going to scroll over to degrees and I'm going to hit enter. Now I'm in degrees, so now I can use my calculator to do these. So to do this first one, I'm going to go 70 times sine 42, close the parentheses, enter. Now, it doesn't tell me how many decimal places I'm going to go to. So if it doesn't tell you, I'm going to go ahead and go to 3 decimal places. So that means little a is approximately 46.839, and this is feet. I'm going to do the same thing for little b. So I'm going to go 70 cosine 42. Same thing, I'm going to go to 3 decimal places. So little b is approximately 52.020 or 52.02. I'm going to go ahead and fill those in my chart now. So 46.389 feet, 52.02 feet. Have I found every angle and every side? Yes, I have, so we're done with that one. We're going to do one more like this, and then we have one problem after that, and then we're done. So number 4, same thing, we're going to be given a right triangle, so I'm going to draw the right triangle. All of these are going to be dealing with right triangle. I'm given angle A up here, angle B down there, and angle C. And I'm given angle B is 15 degrees, and I'm given down at the bottom is 25 feet. Now, before I do anything, I'm going to go ahead and set up my chart. I'll make it a little bit wider this time so I have room. We're talking about angle A, angle B, angle C, little a, little b, little c. What do I know that doesn't require any work? Angle B is 15 degrees. Angle C is 90 degrees. And little a is 25 feet. That's what I know. So now I'm going to circle the angle that I'm given. And I'm going to highlight the angle that I'm given as well. And I'm going to highlight the side that I'm given. In relationship to that angle, across from it is little b, which is our opposite. Across from the C is always little c, and that's our hypotenuse, which means across from A is going to be little a, but in relationship to angle B, that is our adjacent. Now, how do we find angle A? That's one that doesn't require a lot of work. 180 minus 15 minus 90, and we get 75 degrees. So that is 75 degrees. So what do I know? I know adjacent. Which 2 trig functions use adjacent? Cosine and tan. So those are the 2 that I'm going to do. So I'm going to do cosine of 15 equals adjacent which is little a, which, what do we know little a is? We know little a is 25. So I'm actually going to go ahead and just write in the 25 over hypotenuse, C. I'm going to leave that as I set up the other one. Our other one ratio we're going to do is tangent. So tangent of 15 is opposite, which is little b, over adjacent, 25. Same thing, we're going to do ratios. So with the cosine, when I cross multiply, I get c times cosine of 15 equals 25. Do I have c by itself? No, I don't. I need to divide both sides by cosine of 15. Now I have c by itself. For b, if I cross multiply, I get 25 times tangent of 15 equals b. Do I have b by itself? Yes, I do. So now I'm going to plug those in my calculator. So for c, I'm going to do 25 divided by cosine 15. And what do we get? We get approximately 25.882. Then if we go to little b, we go 25 times tangent of 15. We get little b is approximately 6.699. And both of those are in feet. So I'm going to make sure I put feet for both of them. And then I'm going to put them in my chart. Now, do you have to use the chart? No. I'm using a chart so I don't forget anything, because I'll know I'm done when I've got every box in the chart filled out. That's only when they ask us to find all of them. If they don't ask you to find all of them, you don't need to do that. We have one last problem, and this last problem is not asking us to find all of them. All that this last problem is doing is asking us to solve for the unknown. So it doesn't want us to find all, it only wants to find whatever variable they're asking you to find. So this is number 5. So here is our right triangle. And on this one, we're given this is 40 feet. We're given x is here, and we're given this angle is 72 degrees. It's not labeling the triangle, it's not doing any of that. It's just asking us, how do we find x? So if I'm looking at this angle, so I'm going to do the same thing I've been doing. I'm going to circle the angle they gave me. Across from that is opposite. Across from the 90 is hypotenuse. And next to it is adjacent. So is it asking me to find opposite? Nope, it's only asking me to find the hypotenuse. So which of the 3 trig functions uses adjacent and hypotenuse? Cosine. So then I'm going to do cosine of the angle is adjacent, which is 40, over hypotenuse, which is x. Same thing. Cross multiply, and I get x. Cosine of 72 equals 40. Get x by itself, and I divide both sides by cosine of 72. And you get x is approximately, let's plug that into our calculator, so 40 divided by cosine 72, we get approximately 129.443 feet. And that's all we have to do. It's not asking us to find everything else, just that one side. So how you figure that out is you look at what are you being asked for, what are you given. And so now, once we're done with the notes, go ahead and do your summary, and then you can start working on your homework.